I don't think that's the right spelling.
Which Taylor? Like
No, that's definitely not right.
No? How do you spell this now?
I've got the-
IBTALAH.
How do you spell Taylor?
TAYLAH.
Is it a special thing?
It's just a rule
go-
series. I don't know how to spell it, Taylor.
So, f of x is equal to big sigma, n equals to 0 goes all the way to infinity, and the nth derivative of x.
Yeah, it is. Actually, it is. Actually, it is. Taylor.
N over n factorial. So, to do a simple proof of that, let's say we want to find p of x. Give me a random polynomial, Jackie. Not too big. All right, fine, I'll do it. So 3x to the power of q plus 2x to the power squared plus x plus 1. Right? So let's just write this out first. So the first derivative will be 9x squared plus 4x plus 1. Second derivative is 16, is it? Oh, wait, 18x plus 4. And then the third derivative will be 18. Fourth derivative is 0. So now using the Taylor's series, damn, run out of space, I need another whiteboard. All right, so using the Taylor's series, if we expand that out, it's really just f of a, oh damn it, that's an a. Yeah, made a mistake. I should do some video editing like that.
Sure.
Yeah. And then plus, what is it? So it's first derivative of a multiplied by x minus a, and then plus the second derivative of x minus a squared, that's a square, over 2 factorial, plus the third derivative of x minus a cubed over 3 factorial, and then that's the pattern, continues. So if we sub this back in, if we sub a, so if we let a equals to 0, which means we want to approximate this polynomial at the point 0. So if we do that, sub 0 in, that just equals to 1, plus that's a sub-0 in here, that's another 1. And then this is x minus a, so that's a with a0, that's just x. Plus the second derivative, that's 4. And then x minus a, because a is 0 again, so that's x squared over 2 factorial. And plus the third derivative, wait, I'm missing something here. Yeah, I missed something here, there's a here. So plus the third derivative, when we put in a, that's the third derivative. When you put in, wait, what? What have I done? That's the first derivative. Wait, that's the second, yeah, no, hang on, that's the second derivative, and this is the third derivative, yeah. So that's the third derivative. When you put that in, that's equal to x cubed over 3 factorial, plus the fourth derivative will be 0. So fourth derivative 0, if you put 0 in here, so 0 doesn't matter anymore, that's just gone, down just dies. But this one dies. So if we rearrange this again, we got 1 plus x plus 2 factorial 2x squared plus 3x cubed. So end up with the original equation, yay! So that is an example of proof cheap-ish. It's not a proof, it's a cheap example of how the Taylor series works. So what this is saying is that when you're trying to approximate a polynomial at any given point, you end up with the polynomial itself. Hey, do math for fun.